Hey everybody, welcome back to Wine on RV. Thanks for joining me for another episode of Solar Saturday. Today we're going to talk about Watt's Law. Remember, if you want to learn more and make less mistakes while RVing, be sure to hit that subscribe button, drop a like and a comment down below. I appreciate it. Thanks for watching. Now, I know some of you guys might be immediately intimidated and want to turn the video off right now, but just don't do it. Just listen very closely. This is going to be a very short video. I'm going to explain what Watt's Law is and how it pertains to solar. So far, I've really talked about solar panels, solar charge controllers, batteries, and inverters, right? That's what I've basically gone over, is how these systems work. And if you haven't seen that, I'll go ahead and put a link right here in the corner so you can see them. In each one of those videos, I talk a lot about volts and amps and wattage. And that's what Watt's Law is it basically explains the correlation between the three. So to start it off, very simply put, watts equals voltage times amperage, also known as, I believe it's like power equals current times energy, or current times, it's P equals I times V, okay? But to break it down even simpler, we're just gonna call it watts equals voltage times amperage. And if you have two out of those three things, then you can figure out the third thing, right? So if you have your wattage and you have your voltage, you can figure out your amperage, because then you can just divide the two, right? And same thing, if you have wattage and you have your voltage, you can then figure out the amperage by dividing, okay? Wattage equals voltage times amps. Another way of just saying this is voltage times amperage equals wattage, right? Because everyone looks at things a little bit differently. So if you have your voltage and your amperage, then you know how many watts a particular appliance or computer charger or whatever it is takes up. Some chargers say 56 watts and it says that it's, it's a 120 volt thing. So now you can just divide the two and figure out the amperage. Make sense? A big reason I want to talk about this is because with solar and inverters and batteries and everything like that, there's so many different things that things are rated in, and people have such a hard time understanding how to properly size wires, how to properly size solar charge controllers. How much can my 400 watt panel array do? Like what can that do for me? And so that's why I'm going over this formula, is because it should be able to help you understand the correlation of all three and be able to figure out what you can use or what size wire you do need. Because if you know the amperage of something, or excuse me, if you know the wattage of something and the voltage, then now you can figure out your amperage. And now based off of your amperage, you can properly gauge the size wire. Now to talk about it just a little bit more in depth, let's try and get into it a little bit. So voltage, which I've talked about before, is you get higher voltage, you end up needing less amperage for the same amount of wattage, and that's very easily explained in Watt's Law. So if you have a 12 volt battery and you're trying to run your air conditioner that pulls 1200 watts, well, that's 100 amps of power from your 12 volt battery. Versus if you had a 24 volt battery trying to run the same 1200 watt air conditioner, now you're only pulling 50 amps, or half the amount. So with that kind of thing, now you can easily know that, okay, well, based on my inverter size, let's say you have a 3000 watt inverter and your 12 volt system, now you know the gauge wire you need is rated for, whatever it is, 3000 divided by 12, which is 250. So that's 250 amps of DC power that you're using to run that inverter when it runs up to its max. So now you know that you need a wire size that is rated for up to 250 amps, and preferably a little bit more because you want to have a little bit of safety. So right there, bam, you need a 4-aught cable, or a 4/0 cable, in order to properly supply wire to that inverter. Otherwise, you will melt up and burn your cables. And why does that happen? Well, think about it this way. Your power, or excuse me, your voltage, okay, so like I was just talking about, a 12 volt system is basically how fast something is moving through the electrical circuit, okay? So let's say this right here is 12 volts, nice and slow, okay? So to produce the amount of wattage, like we're talking about a 300 or a 3000 watt inverter going at this speed, guess what? You need a lot of current, aka amperage, behind it to be pushing it through. Okay, so you need all that current behind that voltage in order to push it through the wire to produce the amount of watts that you're using. Now, if you're doing the exact same thing and we're talking about 12 volt moving this fast, but instead, now let's talk about using a 24 volt system, okay, it's gonna move twice as fast. Twice as fast. 24 volt system is going to move faster through. So now instead of needing 250 amps pushing behind this 24 volt system, you're only using 125 amps behind it. Does that make sense? And when you have that amperage going through the wire at a faster speed, creating lower amperage, the cable can be smaller, right? So a lot of people use water as a reference point of, you know, turning on your sink faucet and explaining voltage and amperage and stuff like that. You know, the water pressure is the amps, and I just think it further confuses people. But that cable size is so important because those real thick, big cables are needed for that super high amperage current, because it produces so much heat when the voltage is going through there so slowly, and it produces all that heat, and that's why you need those really big gauge wire. Whereas when you bump up to 24 volt, you can go to a smaller cable, and 48 volt, even smaller than that, because the current is getting cut in half each time, right? The amount of amperage is getting cut in half each time. So it's not producing nearly as much heat. So you don't need as thick of a cable because the heat isn't there. When the amperage goes through the cables a lot faster, that's why you don't need as thick of a cable, and because it's not producing as much heat because it's going through faster and more efficiently. I said I wanted to keep this short and sweet. I hope I did. I hope I didn't over confuse anybody. I was trying to keep it as basic as possible. There are tons of videos out there online that go way more in depth to Watt's law and Ohm's law and how all that correlates. But hopefully this gives you a little bit better understanding of for your solar system, for your inverters, your battery system, and how Watt's law can be applied, and how you can then use that to size things properly, to know what type of inverter you need, to know how many panels you need based on what you're going to try and run. That's it for this week's episode of Solar Saturday here on Why Not RV. Please make sure to drop a comment below, hit the like button, hit the subscribe button. Let me know what you want to see in the future. Tell me what other things you want me to try and teach you guys about and show you here for Solar Saturday. We'll see you next time. Thanks for watching Why Not RV. Bye.